As simply as possible, NVIDIA is being a dick. NVIDIA wants everyone to talk about multi-frame generation. We're happy to do that because it is worth talking about, but we can't talk about MFG, which is part of DLSS 4 now, without also talking about all of the problems that NVIDIA has been leaving in its wake and its misunderstanding of how open source PresentMon software even works right now. So NVIDIA has inducted open source software into its FrameView tool. It's made changes and what it thinks are improvements to those tools for its own FrameView software without, as far as we can tell, recontributing them to the open source code. And instead, it's kind of branched it and done its own thing. It then distributed outdated information in its review guide, which is over 100 pages long, for how PresentMon works. Now, in our original discussions with NVIDIA back at CES when they were announcing these cards, they didn't seem aware at all of what was outdated about their understanding, and the v1.1 version of the review guide does technically add in some notes about CPU busy and CPU wait, which we're going to talk about today, but it doesn't change the fact that some of the foundational information in there appears to be just out of date. And it's because they decided to do their own thing and use what looks like a year-old version of PresentMon as the framework for FrameView, rather than just working with everyone else. While NVIDIA has some valid points in how to measure generated frames, the biggest counterpoint is that their statements were just largely based on old, outdated software that's already made a shift away from the MS between presents metric that NVIDIA is now contesting. And yes, they mentioned CPU busy and wait, but we just feel like the entire premise of how this was presented was misleading. The open source license that PresentMon's filed under allows NVIDIA to do this. It's just not a productive thing to do, and we think it's potentially detrimental to testing efforts. So Intel has told us that NVIDIA is welcome to contribute to PresentMon, which Intel maintains, and play nice with everyone else. But NVIDIA is doing NVIDIA things. As for why this is happening, again, this is all relevant because multi-frame generation, which is the topic we're diving into today, whatever you want to call a generated frame, artificial frame, generated frame, or they'll love this one, fake frame. Whatever word you use, they are very difficult to test and measure accurately, and we're only scratching the surface of this topic today. There's a whole lot of other stuff to do, like image quality in the future. This video will first define what DLSS 4.0 is and some of the feature set differences between that and previous DLSS versions. We'll also go into NVIDIA's framing of the benchmarking methodology, the things we agree with, some of the stuff they say is absolutely right, and the things we disagree with. And additionally, we'll talk about the frame generation models and how they perform. We do think there's something interesting here. It's absolutely worth talking about, but it's going to take a couple videos to really get through it all because it's complicated. Before that, this video is brought to you by the Antec Flux series of cases. We previously benchmarked and independently reviewed the Flux Pro case and found it to be one of the best cases we tested last year. The Flux Pro features the modern trend of wood accents while also focusing on a high airflow design. We found its performance to be among the best in our thermal testing. The case also has a number of ease of installation features to make assembly and cable management easier. Learn more at the link in the description below. So despite the problems we have with some of NVIDIA's PresentMon framing and some of the agreements we have with them, DLSS 4.0 is worth diving into. NVIDIA seems aware of how confusing the rollout of DLSS has been and continues to be, and its mix of DLSS version numbering plus differences in sort of this matrix of GPU support versus DLSS version support. That's what's contributed to this. So we're going to try and break this down. You may have seen this chart before that details the feature set and what does and doesn't work across various RTX series GPUs. Some of this is segmentation, some of it is hardware, some of it is potentially temporary segmentation that could change in the future. And because this topic is so complicated, Patrick and I are going to split this one up. So he's going to help with some of the explainer and hosting responsibilities on this. He did the foundational work on writing this piece and has been researching DLSS and the different versions for over a week now. So I want to pass it over to him to get us started with this topic.
Taking a step back, DLSS stands for Deep Learning Supersampling. That name was already strange 7 years ago when it was introduced because supersampling generally means rendering at a resolution above the native screen size and then downsampling it. For example, if you rendered at 4K but you have a 1080 screen, you would get a really crisp image with excellent anti-aliasing. DLSS is kind of the opposite. For DLSS, NVIDIA trained an algorithm on a set of extremely high-resolution screenshots on a per-game basis. And what this meant is that they could do upscaling in real time. For example, you could render a game at 1080 on a 4K screen and it would be upscaled into a mostly okay-looking image. DLSS is no longer trained per game, but the name is stuck around. The use of those training images, those really high resolution screenshots, is what makes it kind of sort of super sampling. All of this was pretty straightforward until the release of DLSS 3.0 in 2022, which introduced optical multi-frame generation.
OMFG, continuing NVIDIA's propensity to use initialisms that contain other initialisms, like MFAA. That was a fun one. OMFG is optical multi-frame generation, later referred to as frame generation 2x or just plain frame generation, because now DLSS 4 has multi-frame generation. Now with this, the original functionality of DLSS was renamed to DLSS Super Resolution, and that means that NVIDIA is now at a point where they can recommend deep learned super sampling, super resolution, ultra performance. Super ultra. I added the last part. As for frame generation
falls under the DLSS umbrella, even though it's not directly tied to upscaling or super sampling. DLSS 3.5 added Ray Reconstruction to the DLSS family, and now DLSS 4 adds multi-frame generation 3x and 4x, as well as changing the underlying model for the other DLSS features. So, DLSS 4, DLSS 3.5, DLSS 3 et alia are groups of features and updates. If a game has DLSS 4, that means it has some of the DLSS 4 features from this chart, most likely multi-frame generation, but not necessarily all of them. The claims that with 50 series AI handles 15 out of every 16 pixels to multiply frame rates by up to 8x are based on using the maximum 4x MFG setting with the DLSS super resolution set to performance, which was formerly the minimum quality setting. That would mean that at 4K, one 1080 frame would be rendered for every 4 frames displayed. As for MFG,
MFG is available for 50 series cards, and as of writing this, no other cards support multi-frame generation. Now, frame generation can be supported elsewhere, but MFG is unique right now to the 50 series. But it's also the centerpiece for NVIDIA's misleading marketing slides, where it depicted the 5090 as doing 2 times the performance of the 4090. This misleading chart that we've already talked about in the review is because MFG includes 4x, which is up to 3 AI frames for every 1 rendered frame. MFG also includes 3x, or up to 2 AI frames for 1 rendered frame. The existing frame generation 2x mode has been improved, NVIDIA says, but it remains exclusive to the 40 series and later, and frame generation in general still only works with games that explicitly implement it. To paraphrase NVIDIA, the original implementation of frame generation combined 4 elements: a previous frame, A, a current frame, B, and, quote, optical flow field generated by Ada's optical flow accelerator, end quote, and data provided directly from the game engine about motion and other elements. Using these inputs, the card could throw together a so-called fake frame, or a generated one, between A and B at the cost of queuing up frame B for a little while. Now, of course, it'd be ridiculous and a fundamental misrepresentation of frame generation if you were to get up on stage and say something untrue, like, I don't know, it can predict the future.
It can predict the future.
Okay, well, that's beside the point.
I wonder if this can play Crisis.
Why does he do this? It can't extrapolate into the future. It can interpolate intelligently into the past. That's the distinction here. And this gets confusing if you think about it too much. This creates the feeling of a smoother frame rate with some added latency, which is why NVIDIA Reflex has always been a mandatory setting when enabling frame generation, a feature that we've covered in detail. Reflex clears the render queue so that frames are delivered with as little latency as possible, which helps mitigate the latency inherent to frame generation. We have a full interview into the technicals of latency just in general, including Reflex, if you'd like to learn more. So fundamentally, we get into one of the key areas that this can be kind of confusing to follow, which is that frame generation in general is not intended, it seems, to turn low frame rates into playable frame rates. It seems instead that it's more like it's meant for turning playable frame rates into high frame rates. And this is still true for MFG, as NVIDIA stated to Digital Foundry.
Acceptable input frame rate is still about the same for 3x or 4x as it was for 2x.
Higher input rates means fresher data for frame generation, smaller gaps to bridge, and then likewise less time to notice flaws in it. So that's kind of the theory of how it's set up. MFG is still bridging the same gap between the newest rendered frame though and the previous one. It's just doing so with up to 3 AI frames or generated frames, or if you want to use a term that NVIDIA probably hates, fake frames. And it's doing it with up to that many instead of 1. On the plus side, this theoretically means that latency shouldn't be worse with MFG than with regular frame generation. Now, to clear up another maybe misconception with this, if you're on a 60 Hz monitor, it would appear that you are not the target audience here for this solution. There's no point in using frame generation to boost your frame rate past the refresh rate of the display. And that's not just our opinion. Rendering at rates that exceed the display refresh rate can reduce latency, but generating frames at a higher rate is just wasting compute power on frames you won't see. This is why NVIDIA's DLSS 4 demos have topped out around 240 FPS. As for the optical flow accelerator, we'll throw to one of NVIDIA's public videos that it's uploaded, where it has its own resident Steve introduce the technology. His name is Brian.
So you may be asking, what is the optical flow accelerator and why do we need it?
And yes, I have met him at events, and yes, we didn't talk about NVIDIA, we talked about how people comment about our hair. Anyway, with DLSS 4, Ada's hardware optical flow accelerator is out of the picture. DLSS 4 frame generation is solely handled by regular tensor cores, which is why Digital Foundry asked that question about frame generation, not MFG, potentially coming to more cards. NVIDIA claims that the new model is faster and uses less VRAM, which makes it feel like the only point of the OFA was to make frame gen exclusive to the 40 series. MFG is not possible using the old model since it, quote, would be required for every new generated frame and the performance cost would throttle the GPU, resulting in lower input frame rates, end quote. NVIDIA did confirm with us that Blackwell, which is the new architecture for the 50 series, does have a hardware OFA unit. We assume here that what they're planning to use that for is situations where games don't implement the new models and maintaining compatibility with games that don't have that updated frame gen model. So time to get into flip metering and some of the issues we mentioned earlier about NVIDIA doing NVIDIA things and its flawed understanding of PresentMon. So we're gonna get into that. This is also NVIDIA's stated reason for MFG being exclusive to the 50 series. NVIDIA has given two reasons for locking MFG to 50 series. First, the 5th generation tensor cores are significantly improved. And second, they say Blackwell has hardware support for flip metering. Flip metering shifts responsibility for frame pacing from the CPU to the GPU driver in order to effectively pace out fake frames, or generated ones, which has become more important with MFG. This takes place immediately prior to scan-out. Again, Blackwell's implementation of flip metering is hardware-based, so it can't be ported to 40 series as is. So this is where we get to NVIDIA doing NVIDIA things and its incorrect understanding of PresentMon and how it works. So PresentMon is a fully open source utility. It is maintained by Intel. It can be contributed to by basically anybody. Other companies like AMD have worked with Intel on maintaining and advancing parts of PresentMon. So PresentMon measures performance. It captures data. It's able to work at a lower level with Windows and help to analyze the frame time and the frame rate performance, animation error, all kinds of stuff. It is the key backbone to most of the performance analysis software that's out there. So even if you don't use PresentMon, if you're an enthusiast who tries to measure your performance, you might use something else that does. Now, Intel's Tom Peterson has joined us several times to explain advancements to it and how it works. It's one of the most trusted testing utilities for measuring component performance, and again, its open source nature is critical to that, especially because it's maintained by Intel. Unfortunately, NVIDIA has decided not to contribute to and maintain PresentMon in a significant way, and that puts us, GN, in a weird position where we're acting like a marriage counselor. We get to talk to Intel on the PresentMon side and NVIDIA on the they don't understand how it works side, but they sure have some opinions. So NVIDIA has instead taken an ancient version of the PresentMon core, inducted it into their FrameView tool, which they build and maintain, and it then proceeded to make adjustments, as far as we can tell, to that code. But it didn't do this in a way where it's contributing to the public and current branch of PresentMon and is instead maintaining its own thing. As far as we can tell, it looks like NVIDIA has chosen not to contribute or work with Intel on PresentMon in a way that would reflect the changes NVIDIA is trying to push in this section we're getting into. Now, this has gotten messy because this results in bifurcation of the PresentMon code into multiple software solutions that might be on different versions that are measuring things differently. This is a big problem, and NVIDIA is sort of at the heart of it. So things like CapFrameX or RTSS, tools like this, Hardware Info, they use PresentMon for the frame rate analysis. Now, we use just the PresentMon actual sort of core code from PresentMon itself, where we use command line for everything we do. But recently, as an example, we introduced Jay's 2 cents to the PresentMon graphics user interface, and he's been doing great with it. So that's kind of the core versus everything else that's using it. Related to flip metering, NVIDIA has pushed hard for a switch from PresentMon's MS between presents metric to the MS between display change metric. While we understand why they're trying to do this, the premise we think is flawed. And that's because PresentMon already switched away from MS between presents. But NVIDIA pulled us aside at CES and told us why it's time to switch away from MS between presents. And then it had a massive section in its review guide about why it's time to switch away from MS between presents, or milliseconds between presents. So again, this kind of goes back to that already happened, but NVIDIA's using old code, and so it's sort of like being the last guy in town using candlelight, walking outside and saying, I have a great idea, what if we switch to electricity? We think NVIDIA's FrameView software is most likely based on PresentMon 1.10.0 from February 2024, based on inspecting the results output. The current version of PresentMon 2.3.0 no longer supports either of the metrics NVIDIA is talking about under those names. It instead switched to a frame time metric based on CPU busy and CPU wait, which NVIDIA says is also inadequate, but which Intel began talking about around a year ago. MS between presents is an ancient metric inherited from Fraps, which was basically the only frame time tracking tool around when PresentMon began development. It tracks time between present calls, which tell the graphics engine to finish up and put the frame on the screen, but it doesn't reflect animation time or time on screen. Despite NVIDIA's decision to not participate in working on the tool that everybody else does and instead build its own outdated toys and its own playground, it does have one good point in all of this, which is that the valid part is situations such as MFG, back to what we're talking about today, have a problem here. And the problem is there's external frame metering very late in the pipeline that may make the on-screen frame rate smoother than MS between presents would imply. But we don't think MS between display change is sufficient either, and that's what NVIDIA is saying everyone should use. Milliseconds between display change also doesn't track animation time. Intel defines it as, quote, how long the previous frame was displayed before this present was displayed in milliseconds, versus MS between presents, which was, quote, the time between this present call and the previous one in milliseconds, end quote. In contrast, the current PresentMon frame time metric is the best estimate of the time between the game taking snapshots of its physics engine. However, milliseconds between display change as a metric does take into account flip metering for NVIDIA's MFG solution, and so it makes sense to use it specifically for tracking NVIDIA's frame generation. And we mentioned animation error, which we've talked about again with Tom Peterson in the past, and this is important. Just because frames are delivered at an even pace doesn't mean they look good, and it doesn't mean that things being shown in those frames have been animated at a consistent and even pace alongside the pacing of those frames. And animation times and flip times have to be consistent. This was a problem with SLI and Crossfire, where frames could be delivered at a constant rate, but could appear stuttery anyway, because animation timing didn't line up with the flip timing. Ideally, in the long term, we'd move towards using FPS as a metric for raw horsepower and animation error as a metric for smoothness, so to speak. But that's outside the scope of this piece. So there's a lot of technical background on measurement tools and how important they are for all these new technologies coming out. But to put a very fine point on it for, okay, so what? What does all of this mean? The so what is NVIDIA's being a dick, and it's specifically doing so about PresentMon, an open source tool, and it's then claiming that, quote, FrameView has solved certain bugs to make milliseconds between display change accurate in more scenarios, end quote, without communicating those changes to the developers. When we talked to Intel about this relating to PresentMon, they basically said, well, NVIDIA can talk to us if they want to, but somehow we're filtering it. So that puts us in a situation where in order to test MFG and have any sort of, hopefully, accuracy to it, we have to use NVIDIA's version of an open source tool that NVIDIA has closed off to measure NVIDIA's hardware with NVIDIA's new technologies with supposedly bug fixes that NVIDIA has not explicitly disclosed. You can see why these are a lot of problems for measuring an NVIDIA product. It calls into question the entire premise of the metrics because there's no external way to really thoroughly inspect what it is NVIDIA's been doing behind the scenes. Now, this isn't illegal under PresentMon's current license, but it is rude. AMD is even currently collaborating to support tracking fluid motion frames, but NVIDIA is not. So anyway, let's get back into MFG and DLSS now that we've gotten all the measurement discussion. This is all really important because measuring these fake frames is not necessarily trivial and it requires some real serious planning on the tools being used. So anyway, we can talk about image enhancements next. NVIDIA is switching away from convolutional neural networks to a transformer model for DLSS, rolling out as a beta. This change affects all RTX cards. The gist is that the new model should have a better understanding of which areas of the screen are important, and therefore has a, quote, greater stability, reduced ghosting, higher detail in motion, and smoother edges in a scene, end quote. This is an image quality improvement, not a performance improvement, and may actually worsen performance a bit. NVIDIA notes that, quote, while Ada and Blackwell both benefit from this new model, the transformer model is often more performant on Blackwell, end quote. And we'll show our own results in a few minutes here. For each of the DLSS 4 features we've discussed, the new frame generation model, MFG, the transformer model for DLSS SR and RR, there are now driver level overrides. For example, with a game that supported the original FG and a card that supports MFG, you could use the driver to force MFG. This is a whitelist system, so not every game will support overriding. And the ones that do won't necessarily have every DLSS 4 feature available. We don't expect this to get a ton of use. The interface is currently confusing, and we'd assume that most developers willing to go through the hassle of getting whitelisted for overrides will just update their games. There are plenty of other new features that were announced alongside the 50 series, but we're just talking about DLSS here. Reflex is technically not DLSS, but it is a dependency, so we're throwing it in. Reflex's new feature is frame warp, which is similar to the reprojection tech that's been used in VR. It checks mouse input at the last possible moment, and if it detects an update, it shifts the camera over to approximate the correct movement. The unrendered pixels are then painted in. Whether or not this represents a literal reduction in latency is arguable, but it should feel like it. Time to get into performance testing. This is really complicated for all of the wrong reasons. So we have a couple groups of comparisons here. Our first and primary objective is going to be to compare the old and the new models for frame generation to each other. And so what we're looking at is what's the difference between the two models. We're not looking at the 4090 versus the 5090. We have both sets of results, but it's not a comparison of cards. It's a comparison of models running on cards for frame generation. There's a couple challenges of analyzing so-called fake frames, and one of them is that there isn't a clear amount of generated frames necessarily. So in other words, it's not necessarily consistent how many generated frames there are. And that poses a challenge. Another challenge is that although we will have a control on the charts for raw frames, pure frames, the purest of frames with no artificial pixels in them, whatever you call those, normal frames, we're gonna have a control for those. But generated frames, by the very nature of them, are not a like-for-like comparison because they're not the same frames. They contain generated data. And so the whole thing is just, it makes it challenging to do true head-to-head comparisons, which is why we have such a problem with NVIDIA its marketing charts, but that's a different discussion. All right, so our test bench is detailed on the website. It's free of third-party ads, and it includes the hardware configuration. You can check that out, scroll through it, see the hardware if you want to see it. And another important thing is that we're not covering image quality in this piece. That'll come later, but we'll go over performance numbers today. Image quality is an entirely different deep dive. NVIDIA provided 6 games to the press with the new DLSS 4 features available. We dug through them to find some way to isolate the features for testing. 4 of the games had native feature implementations and 2 were whitelisted for driver overrides. As mentioned earlier, we were forced to use FrameView for all benchmarks involving frame generation. For the purposes of these tests, we're including generated frames in our averages. Our first task is to compare the old frame gen model performance versus the new frame gen model performance on the 4090 and 5090. The company hasn't claimed that image quality will change or improve with the new method. The only two games available to us with both models were Marvel Rivals and Dragon Age Veilguard, both through driver overrides, but we were also able to make a usable comparison with Hogwarts Legacy. We're using the games that work with it. For the charts coming up, focus on the red versus the orange bars. That's where we're looking at the two models. The blue bar, which is the control baseline, no frame generation, it's kind of questionable whether that can be directly compared to the FG models because of the differences we already talked about. There's one other confusing aspect as well. If we want to compare the impact of overhead on real frame rendering as well, then we'd need to know how many fake frames were generated in the fake plus real frame rate to then compare against the real frames in the real only frame non-generated rendering. In other words, if the frames are half fake, then we need to real cut the fake frames in real half, because the half fake real halving would real halve the percent uplift caused by the half fake frames, but it's not clear if you can just divide by 2, because MFG generates up to 3 fake frames that are fully artificial for every 1 real frame, but then it's up 2, and so it's not as easy as maybe just dividing. And anyway, this is getting way too complicated. You can see exactly what the issue is with all of this. We're gonna put numbers on the screen, and then our solution to the complication is we're going to read the numbers that are on the screen and do percent comparison between the two models. That is the simplest thing we can do. You get the idea. It's a very tricky subject. This benefits NVIDIA with it being tricky, and the whole thing is kind of, it's challenging to say how precisely like for like anything is, but that is the nature of artificially generated data. So let's get into some charts that are real of at least half fake data, but that's real, so here they are. Here's Dragon Age Veilguard at 4K with max settings. We manually increased it above the highest preset for this. DLSS, Super Resolution, or SR, and AA, or anti-aliasing, were not used for these tests, and Reflex was enabled, even for the control runs without frame generation. Each card should be compared against itself here, so we'll start with the 4090. The new model with FG2X on the 4090 ran at 107 FPS average against the old model's result of 100.7 FPS average, an increase in fake plus real frame perceived fake plus real performance of 6.26 probably real percent. If we were to filter out the fake frames to only real frames to real evaluate the fake overhead, then that percentage comes down. Hopefully you're following. The RTX 5090 ran at 143.4 FPS average on the new model and 136.4 on the old model, an improvement in the as-captured result of 5.1% uplift in perceived performance. Again, there's more nuance if you filter out the artificial frames. Hogwarts Legacy is up next. This one didn't have a driver-level override for the frame generation model, so we had to control that variable by switching back and forth for the press build, otherwise the results would be invalid. But, complicating it more, ray tracing features were updated in the press build, and that would make it invalid. So we disabled all RT effects for these tests. We first compared the public and the press versions of the game with frame generation off to ensure that the comparison even made any sense and was a valid comparison. Disabling RT effectively equalized the performance between the game versions. 107.3 to 106.9 is with an error, as you see in this chart, and 151.9 to 152.6 is also with an error. That makes these valid between the versions under these specific conditions. That brings us to this chart. In Hogwarts Legacy, the 4090 had a 14% uplift in perceived performance from 153 FPS to 175 FPS average with the new model, while the 5090 had a 10% uplift from 224 to 247 FPS average. Working backwards based on the output frame rates, we can deduce that the new frame generation model is easier on the GPU. This allows more resources to be dedicated to rendering. It enables a higher input frame rate, and that then comes back around to benefiting frame generation. The other piece of the puzzle will be determining whether subjective image quality has changed in a later video, but from a performance perspective today, switching away from OFA is better. The second feature we tested in isolation was the old convolutional neural network model versus the new transformer model. This affects both DLSS Super Resolution and DLSS Ray Reconstruction. We were able to test SR in isolation, but RR, Ray Reconstruction, requires SR to be enabled. Again, an infinite list of nested variables. First up is Veilguard again, and using the driver override feature for A/B testing. Ray Reconstruction isn't available as a feature in this game, so this is purely a super resolution test. We used the DLSS SR quality preset, which, given the 4K output resolution, means a 2560 by 1440 render resolution. On the 4090, performance suffered using the new transformer model versus the older CNN model, with the older model retaining a 5% performance advantage. The no DLSS control results is included for context, but that's not the comparison we're focusing on here. On the 5090, the older CNN model had a similar performance advantage of 4%, averaging 105 FPS versus 101 with the transformer model. The difference between the performance degradation on the two cards is minuscule here, but these results would technically align with NVIDIA's claim about the transformer model being, quote, more performant on Blackwell, end quote. The differences are too small here to make that a firm conclusion. What we can say with certainty is that the new model is a little lower performance than the old one with Veilguard. Cyberpunk 2077 Crashing Liberty is up next. When it works, it has Ray Reconstruction as a feature, so we were able to test both DLSS SR alone and DLSS SR and RR in combination when it worked. As noted during our DLSS 3.5 coverage, it's possible for Ray Reconstruction to raise or lower performance depending on the systems that it replaces in a given game. However, it continues to have no significant performance impact in Cyberpunk. We recorded results without Ray Reconstruction, but we cut them from these charts because it made no difference. The losses aren't huge. The 4090 with DLSS and Ray Reconstruction dropped from 71 FPS with CNN to 68 with the transformer model. 5% advantage for the old model in terms of performance. On the 5090, switching to the new model dropped average FPS from 92 to 86, a 7% performance advantage for the older model on this card. Anecdotally, we noticed that the newer model reduces ghosting and visibly improves the appearance of animated textures in Cyberpunk. So this level of performance loss is likely an acceptable trade-off. That comes back to a future image quality piece though. Because the new DLSS SRR model comes with a performance hit, unlike the straight upgrade to FG, do we have enough acronyms for you? We expect many games updated to support the model will take the same approach as Cyberpunk, hopefully without the crashing, and offer a choice between CNN and Transformer in settings. Hopefully, those toggles actually work, also unlike Cyberpunk, because they remain problematic in this game. We always relaunch games between settings changes of any kind, but we noticed that relaunching Cyberpunk with our specific settings would switch to the Transformer model invisibly while claiming to still use CNN in the menu. We were forced to toggle CNN off and on from inside the game in order to test it reliably. All of this was observed in the public 2.21 Steam release. This is an extremely subtle bug. It wastes a huge amount of time, and it could invalidate data. So, to be as efficient as possible, we'll just recycle our Cyberpunk rant from 2 years ago because it's still valid today. Here's a clip. Also, if CDPR is listening, please fix the settings menu that we talked about earlier. Individual settings get reset constantly for inscrutable reasons. We've had situations where we've applied settings, clicked run benchmark in the settings menu, then the settings at the end of the bench were different from the ones that we'd set at the start. It's extremely difficult to have confidence that the settings are ever what they say they are. Our final performance comparisons are frame pacing with frame generation enabled. This comes with two major caveats. First, we're using frame view for logging, so the plotted frame times are milliseconds between display change. Second, we don't have a way to toggle frame metering on the 5090, so we're forced to make a general comparison between FG2X behavior on the 4090 without frame metering versus the 5090 with frame metering. Ideally, we'd run the FG4X on the 5090 alone with versus without frame metering. The new FrameGen model was used for these comparisons. So here's Dragon Age again. As always, making a comparative plot is complicated by the fact that the higher performance card renders more frames. The 4090's plot shows the kind of up and down variation between every frame that might be expected from frame generation, with the majority of the pass oscillating up and down by 1 to 2 milliseconds on each individual frame. That may not be enough to cause a visible problem in this title, but it's a good illustration of the problem that NVIDIA is trying to address. The 5090 actually had visibly wider deviations from the average on the whole, but the up and down deviations didn't occur between every single consecutive frame. We'd want to see much flatter lines, even still ideally. Most people notice excursions at 8 to 12 milliseconds. We're not there with this chart, but based on prior interviews we've done, that seems to be where people notice it. You'd still want a flatter line ideally, though. Hogwarts Legacy showed results closer to what NVIDIA promised with frame metering. The 4090 still exhibits some up and down behavior between individual frames as real and fake frames alternate, while the 5090's frame times are clearly more stable. The game also renders at a very high frame rate though, so the actual time delta in milliseconds between frames is minuscule even on the 4090. The 5090 also doesn't completely eliminate the occasional frame time spike. We still see those in this chart, with a particularly large one shown at the end of this pass. So we arrive here. This is one of the videos where jumping to the conclusion is going to actually cut out a lot of really important stuff, like measurement, methodology, and all of these different things that NVIDIA's they've got their way, they want you to do it. And we just think that it's kind of a bullshit reason, because look, they could contribute to PresentMon like everyone else, and we could make it a lot less complicated. But anyway, breaking down DLSS 4 into its individual components, the new frame generation model does perform better, broadly speaking, and there shouldn't be a trade-off in visual fidelity. But we haven't fully confirmed that yet. We've just kind of anecdotally looked at it. We have a separate image quality comparison that we're going to be working on. We haven't started yet. I think we're starting tomorrow probably. And that's where we're going to look at the image quality trade-off. So this is a very big topic, and it has a lot of composite parts. We're going to tackle it in pieces, and then we'll be able to form a full picture from all of that. Latency is another one of those things that we're going to be looking at as well in relation to all of this. So this is, just to be clear, this is only a part of the story, which is intentional, just because we want to really go in depth with every part of it as much as we can. But anyway, the updated model also theoretically makes single frame generation possible on tensor-equipped RTX cards. And NVIDIA has at this point made no indication that it plans to support that, but in theory, it could be supported on things that are not currently officially supported. The new transformer model for DLSS SR and RR performs worse than the older CNN model, but it should also look better, and our experience so far, anecdotally, suggests that it is worth it for that. We'll follow up with that. Frame pacing with frame generation enabled should be improved versus the 40 series, but this would mostly apply to MFG, and the 40 series can't do MFG. Still, our extremely limited testing on that aspect does show that frame metering has an effect. We'd also like to really drive home this one key point, because it keeps coming up, not just online, but even in discussions in the office where other people who aren't part of this project are kind of asking about it. The same concept keeps coming up, which is that frame gen is really to make already acceptable frame rates into so-called smooth frame rates. It's more of a smoothing thing than it is a corrective thing. So kind of break that habit that Jensen Huang has reinforced on stage, that it fixes a problem, because what it's really doing is helping something that's already acceptable just be a little bit smoother. But it's not going to fix a 25 FPS sort of native rendering rate and turn that into something that feels like it's truly 50 or something like that. You're not going to get that experience in the same way as a native 50 would in that example. So the place to use this would be things like 4K 240 Hz OLEDs that have been coming out recently. Sometimes NVIDIA seems aware of this, and other times it decides that it's not advantageous to be aware of it. Like when it says that the 5070 is equivalent to a 4090 because of MFG. Even though in that presentation, in one sentence, he makes it very clear where he's like, 5070, $550 equals a 4090, all because of AI.
4090 performance at 549. Impossible without artificial intelligence.
And then literally the next sentence, he drops the because of AI part, and it just kind of morphs into 5070 equals 4090. See previous sentence for the really important caveat. If you have bad performance, frame generation may disappoint you. DLSS Super Resolution is a more helpful option in that situation, where you can just modify the actual render resolution and gain some more frame rate through that method. So that's the way to think about this stuff, we think, for now. And we're really just getting started on this. It's fun. There's a lot of cool stuff that we get to look at with this. And part of that is because NVIDIA is inconsistent with when it claims certain things. And we think that there may be strategic reasons for that. And it would benefit them if it's a little confusing sometimes. It could also just be that people are actually legitimately confused about all this stuff. That's what we're trying to help with. We have been ramping on this because it's a really detailed topic. I mean, the review guide is like over 100 pages long, and we read that, and we had a lot of complaints about some of the stuff they wrote in there. We talked about a lot of those today. But even still, it's complicated. So next things are image quality. We're going to work on that, and then I'd like to do latency. I don't know what our timeline is on latency, but IQ we're going to work on next. So keep an eye out for image quality comparisons. And otherwise, a lot of cool stuff coming up. We have some more GPU coverage to kind of close this out with the ITX case testing with the flow-through design. That's going to be really fun and just kind of a scientific experiment. And then we also have some impact to CPU tower cooling performance in a traditional ATX case with that dual flow-through. That's something I'm just personally really excited about because it's a fun test. It's the kind of stuff that I love working on just to see what it does. But beyond those, we're probably going to start looking back to pre-builts and cases and things like that to get you some more content diversity. But there's a lot of stuff for GPUs right now, so stick with us through that. And at the very least, we have some fun feature tests. Check back for more. Subscribe. As always, you can go to store.gamersnexus.net to help us out directly with this testing and the amount of additional information we try to provide these days in the videos. And you can go to patreon.com/gamersnexus if you want to throw a few bucks our way to help fund our operation. Thanks for watching. We'll see you all next time.